Okay, hi everyone, welcome back to Infinite Math Help Squared. In this video, we're gonna attempt to break down the mysterious trig function graphs, right? Why do they look the way they do? What's up with them? They are not as intimidating as I think they are, and I'll show you why. So, trig functions are actually circular functions, right? And hopefully this video breaks that down for you. Let's think about things that are a circle that you could relate to. And one of those things is a Ferris wheel, right? Whether you like rides or not, I know that you're going to understand what they are. They are circular, and they are typically on, don't mind my circle, typically they're on some kind of platform, right? You have to walk up the stairs to get to it. And then it has these little cars that you're gonna get onto, and while you're sitting in the car, you're gonna wrap around this circle. It's gonna move at a constant speed, which is one of the reasons why we can use I don't even know if I made that symmetrical. I didn't make that symmetrical very much, but you get the point. You're in a car, you're happy or sad because you're afraid of heights and someone wants you to go on the ride with you. So for the case of explaining the trig functions, for now we're going to ignore the platform. Just ignore the platform. And I want you to imagine that this is actually the coordinate plane, this Ferris wheel. Let's pretend that it's on the coordinate plane and we're moving around in a circle at a constant speed. Okay, so let's represent the height. So according to Google, the average height of a Ferris wheel is about 65 meters, and I'm, for the sake of my graph and helping you, are going to use 60 meters instead, because then I can split it in half, 30 and 30, right? We can say that maybe we have 30 meters height here and 30 meters height here, and then the total is 60. Okay. We're also going to do it in seconds, because if I go by the average speed of a Ferris wheel, then I can break down my seconds here, and we could talk about what is it going to look like if we graph someone's car movement from the start to the finish. So let's take a look at what that looks like. At the beginning, when you load the cart, you're at ground zero, right? But as soon as the attendant starts it up, it's going to move at a constant speed. And then let's say after 9 seconds, I'm already over here halfway. Then that would put me at 9 seconds and 30 meters tall. And remember, we're ignoring the platform. So we're just going by the cars and the height from the start when you load up to the max height. Okay, then let's say another 9 seconds passes, and now I'm here at the top. So at 18 seconds, I've reached the maximum height. Now, another 9 seconds passes, and what happens is now I've lowered, actually. Even though I'm in a different position of the Ferris wheel, my car has actually lowered in height, because I'm not going to go up into the sky, right? I'm going to come back down to the ground. After another 9 seconds, I've finished one revolution, and I'm back down where I loaded the car. Now, this is actually just going to keep happening and happening until the ride is over. So what I can do here is I can just continue the pattern. I can move over 9 seconds, and I know that I'm halfway. Move over another 9 seconds, and then I know that I'm at the max height. And then it's just going to happen again where I come back down to the ground. And then watch what happens now. If I connect the dots, right? If I connect the dots, what do I have? I have a wave. And it's just going to keep happening over and over and over again. And that's why your trig functions are circular functions. Because now if we look at the math of it, right, and we think about the unit circle, if you need a video on a unit circle, I'll link that in the description at the end so you can have access to that. But if we look at a basic unit circle where the radius is 1, and we use our points, and the fact that the cosine is our x-coordinate and the sine is our y-coordinate, then we can graph a sine function, and we're going to expect the wave that we got here because we're moving around a circle. right? So let's look at the sine at the very beginning. This is where we started on the Ferris wheel, right? We started at ground zero. So at ground zero, what is the sine at that moment? The sine at that moment is 0. So I'm here just like I was with the Ferris wheel. And then what happens if I move to the 90-degree mark? Well, the sine there is 1. So if I go, and if you need a video for radians to degrees, I could do that too. But pi over 2 is 90 degrees, and that means that I've hit the 1 on the unit circle. Keep going. And at 180 degrees, then my sine is back to 0. I'm going to move down here to 270, and now my sine is actually -1, right? But in the Ferris wheel, we don't drop below ground, so that's why it stayed above the x-axis. But here we come. Now we go over here, and we've completed the revolution, and we're back to where we started. And then here you have your sine function, and that's why they look like that. So I hope this was helpful and demystified our trig graphs.